And you are recording, so perfect. Thank you everyone for joining us this morning. We have Gabe Derrick, our project sales manager, who is going to talk to you guys about the Litz Cord Antenna System. So this will be recorded and Kendall will send that out later today or tomorrow. So keep an eye out for that, please. We also have Jake Pryor, who is another project sales manager who is helping out running the computer portion of this activity. So thanks, guys.
Yeah, thanks, Elsa. So we're here today in the park to display the Litz Cord Antenna setups. We have a couple examples. So we have the 30-foot Litz cord in pass-by orientation, and then behind me you can kind of see strung between a couple trees is the 60-foot pass-through. So the pass-through orientation is something new that we're trying to perfect at the moment, and we'll have a mounting hardware kit available for purchase here soon. We're just dialing that in, and we've gotten some really good results with that product. So I'm excited that we're bringing that on board, and hopefully we can get some applications out there, get feedback from our customers, and develop it even further. So my goal here today is basically to identify all the components, what makes up a Litz Cord Antenna System, and then what to expect when you get your package, and how can we get you set up and deployed as quick as possible. Also, we're just going to go over some of the variables that can happen when you get your Litz Cord antenna. You get out there, you deploy it. What you may need to do is make some slight adjustments to the capacitor pack to make sure we're dialed in and operating at our full potential, what that antenna is designed to do. And then I'll give you a couple different options of our enclosures, and maybe even some of the power options that we have available for this system. So without further ado, we'll just dive into it. As I'm sure Elsa's getting footage of now, this is the 30-foot Litz Cord antenna. And in pass-by orientation, we sell these plastic rungs here, and it's just a composite plastic, and we go ahead and zip tie them. I'll show you down here how easy it is to actually install these. Sometimes when you get your antennas for shipping purposes, we'll go ahead and leave these off, and it creates kind of a smaller package for us to send to you, a little cheaper on shipping for you. So heavy duty zip ties with the stainless steel pin in there. So what we'll do is send you enough to space these out about 3 feet. So in this 30-foot Litz Cord antenna setup, there's 9 rungs. And we'll move down here to the end here just so I can show you exactly how easy it is to go ahead and install these. They're pre-drilled, so these zip ties will fit through here. So we're just going to go ahead and slip the zip tie through. We're going to wrap it around the bottom of the cord. Get it in the right orientation here. We're going to come back through the bottom, and we're going to go ahead and secure this zip tie. Now we went ahead for most of these. I'm going to leave this here just so we can move on. But you just come back here and snip these off, and we've done that along the length of the antenna here. So fairly easy to go ahead and install these rungs, and what it does as well as space the antenna, gives that coil configuration that we want, basically 30 feet long at about 2 feet of spacing. What that does is allows us to create a capacitor pack for the antenna to allow it to tune in most applications. Again, you may have to go ahead and open the serviceable end of the capacitor pack and make some slight adjustments, but that's something we'll go ahead and go over so I can show you how easy it is once you get in there and start working. So we've gone over kind of the Litz Cord antenna, what it looks like in pass-by orientation. These cord rungs also give you anchor points, which I'll show you some of the smaller anchors we have for, slow moving streams, terrestrial applications, some to keep it in place so that, we're not washing it downstream. So we have a couple different anchor choices. We can use our regular duckbill anchors like we use on our stout antennas. But in general, we've got some of these mini anchors, and we'll send you enough of these for one per rung. So we've got our duckbill anchor with a small piece of stainless steel braided cable here onto a swage. And then basically what we're doing, and I can kind of show you here, is we're creating an anchor point by shoving this anchor through here. Then we'll use our hand drive steel, which you can see here, enter that into the duckbill, and then by sledgehammer, post hole driver, anything like that, we'll go ahead and bury these in the substrate. What you'll want to do when you're actually installing these is you'll have your hardware on your end. We want that to stay at the end so that we get full penetration into the substrate, you know, all the way through the piece of all thread going here, right? Then what happens is basically you drive the anchor into the substrate like this. You start tightening on this nut. We get some retention as the cable pulls up this way, and it locks it nice in place. So that's kind of the gist of the antenna, how we get that anchored into the substrate, how we keep it in place. Now I'll kind of go into a little more of the construction. So we have a couple pass-through fittings into the serviceable adjustable catboard assembly. Now we have a bunch of hardware that seals this O-ring together. As you can see here, I kind of open it up so that we can look inside. We have our adjustable catboard. That's got 64 different settings in here that we can manipulate the capacitance of the antenna in order to keep it in tune. So the whole purpose of this serviceable adjustable catboard is so that we can dial in the antenna to your specific location, right? So what we're going to do is we're going to send you what you need, or for the general public, I guess, of you know, what should work in your application. But as soil compositions can vary, water levels can vary, we just need to have a little bit of adjustment to it. So on the other end of here, so we've got our serviceable cap assembly that has an exciter cable that goes out. In this specific instance, we have a 20-foot exciter cable. So what that's going to allow you to do is have about 20 feet between where you need to set your enclosure and where the antenna needs to be into the river. We do have an alternative setup, which I'll show you in pass-through orientation, what's called the serial DOP setup. And what that allows us to do is actually get this enclosure much, much further away from the antenna without suffering any performance. So really what we're trying to do is keep the reader as close to the antenna as possible so that we get the full potential, the full current coming out of the IS 1001 reader going to the antenna. And that really equates to performance, right? That largest read range as we can get. So again, we've got our exciter cable coming out. That's going to a 20-foot, basically an extension cable coming back to our enclosure. And if Elsa can kind of see what we got going here. So this is the small scale kind of solar system that we have housed under here, and we'll take a better look at the pass-through orientation. I've got a solar setup kind of where we can see it, but under here is your solar charge controller, some breakers, and then we have an on-off switch coming up to our IS 1001 reader. Now, the nice thing about this system is it's clean, right? So we've got our 2 batteries, our reader, and our solar power all contained in one job box that can be placed on shore. It's got some metal tabs here, so it is a plastic box, but it is lockable. And you know, if you needed to run a chain to a tree or something like that to keep this kind of secure, hopefully deter some theft on your system, we have that ability, right, to get it all in one. We can do it on a larger scale in a metal job box. We can also go a little bit more compact into a portable IS 1001 reader enclosure, which is more just like a Pelican case. So we have a lot of different options for our enclosures, and we can scale up or scale down as much as you need. So it's definitely something, if you have specific needs, we can go ahead and take care of that. So what's seen in here, we'll just kind of go over the enclosure. So the largest batteries that we can put in here are 115 amp hours. So I believe that's a group 35 case size. but it fits nicely. They've got the battery trays in here that kind of secure the batteries in place. And then our current configuration is basically just a couple alligator clips. So there's no need, since this is a 24-volt reader, there's no need to have that jumper anymore to put your batteries in series. We basically do that down below, and it's just a couple alligator clips, or a couple sets of alligator clips that we put onto the system here. So again, if we shut the lid and without the, or with the sun out here, it might be a little difficult, but also if you can pan towards the back. So another nice thing about this enclosure is that we have our exciter cable here coming right out the back. We also have our PV cable, and through some of our customer feedbacks, we've also actually included a ground lug here for instances where we might have some interference and we need to ground this enclosure. We have that capability in this nice small compact case that we have in front of us now. Again, we can go about 50 feet away with our solar panel if that's necessary. And what you see there is a 315 watt solar panel that should keep this IS-1001 up and running in most cases. We can also scale up to multiple solar panels in series or parallel if necessary, if you're you know, I guess in the upper half of the US and sunlight becomes an issue. So that in general is kind of the system in how it's laid out. I've provided a couple different enclosure options for you, so that you know what you see is not always what you get as far as what I'm showing you here. We have a lot of different options for controllers. The antennas I didn't cover, but they're available in 30, 40, 60, and 80 foot lengths. And we've done some testing. We know that in pass-by orientation, all those are going to work well for you, as well as using the pass-through orientation. So with that, I want to show you, and I'm going to switch this the screen over to Jake, I believe. And what I'm going to show you is what happens when you need to make slight adjustments to the capacitance. So when Jake pulls up a screen here, we're gonna see some diagnostics, and you're gonna excuse me. I'm gonna get on my phone so I can see what Jake's seeing as well. And what we'll do is we'll make some fine-tuned adjustments to that capacitance in order to show you how to do so, and how to do so successfully and confidently, because I know it's not something that most people are familiar with. So looks like we've got Jake's screen on there, and I'm gonna see if I can read there. So what we have right now, and you can see on the screen, is we're checking out that capacitor value. So right now we're sitting at 403 on the capacitance, right? Well, let's say you get into a situation where you deploy your antenna, and we're in that lower range. We're in the 200 range or so, and you know, for the IS-1001, the optimal tune range is basically, or the tune range of the IS-1001 is from 0 to 1023. So at 403, we're pretty well in the center of the tuning range of that reader. But let's say we're not. We're down low. So how do we bring that number back up towards, you know, halfway, 600, 400, something like that? So what we're going to do is we're going to lean down here, and we're going to see our jumper configuration. One of the things that will be available on the website shortly is the quick start guide, and it kind of gives you some pointers on how to make these tuning adjustments, as well as including a tuning matrix. And probably for those of you watching now, you can't really see the fine print here, but I assure you we'll make this available for you online, so you can have access to it. But what we're really seeing right now is we're going to try to make that 402 kind of climb up a little bit further. So we've got to look at the current jumper configuration that we have on the board, which what I see in front of me here is the jumper configuration 1.6. Now on our tuning matrix, that equates to about 6,174 picofarads. And again, this can be a little confusing for our customers. So we're trying to let you know and kind of give you a little bit of guidance here, so you can gain that confidence. When you're in the field, you can do this on your own. If I want to make this number, that 404 number, 406 number, if I want to make that go up, basically what I need to do is remove capacitance. So it's an inverse relationship. So if I remove capacitance, that capacitor value on the screen is going to go up. If I add more capacitance to the adjustable cap board, it's going to make that number go down. So what I want to do is, if I want to move that number going up, I'm going to remove capacitance. So I'm going to go from jumper configuration 1.6, and I'm just going to remove the 6. So it's pretty easy to do. What you'll want to do is basically keep your fingers and everything away from the metal, because right now the system is in scan, which I'm pretty comfortable doing. But if you need to make adjustments, you can put the reader in standby very easily, make your adjustments, go back, put your reader in scan, and then observe those changes. So if Jake can go back to the capacitor value there, so we've changed just ever so slightly, but we've gone from 404 to 410. Now, what you'll learn overall, doing this process numerous times, is that the number six jumper here is probably the most minimal value change that we have on the board, based on the configurations that we have. So anyway, we slightly moved that just by pulling that number 6 jumper. And you saw that as removing capacitance, I raised that capacitor number that's shown in Biostat right now that Jake's showing. So if I reinsert number 6, we should go back to that lower value, which we see 403. So I'm going to show you the opposite of that. If I wanted to go ahead and add capacitance, I'm going to do the opposite. So instead of going from 1.6, I'm going to make a slighter larger jump here, and I'm going to switch this from 1.6 to 1.2. Again, this is simply by following the matrix that I have in front of me. It's relatively easy. And what we saw there is we saw that number decrease, right? So we drop that number. So let's just say you're up at 800 or something like that. We want to go more towards 600. This is what we would do. We would add capacitance to the adjustable cap board in order to see those results and get our antenna into a better tune range, or in tune if it's out of tune. So I'm going to replace this again. Just go back to our original setting, remove the jumper from 2 and go into 6. And then we'll see that number climb back up to about 403. So overall, that's pretty much the process of making adjustments to the adjustable cap assembly, right? So step 1, remove all your hardware from the lid of the adjustable cap assembly. Step 2 is sometimes the jumpers are actually zip tied to one of the cables, so we'll just remove those, so you have all the little jumpers for the adjustable cap board that you need. You'll make your capacitor adjustments through the adjustable cap board using that matrix in order to get your antenna to tune in that optimal range. So that's pretty much the gist of the adjustable cap board and how we do that. Then we go ahead and replace all that hardware, ensuring that we don't have any cabling in between the gasket or the lid, anything like that. It takes a little bit of getting used to, but just making sure that this goes back in the sense of original sealing. So yeah, it's fairly simple. Once you've done it once or twice, you'll get confident with it, and more than likely, once you do it once, you theoretically shouldn't have to do it again unless you pick up and move the antenna. So once you get it kind of in the middle of the board there, then the auto tuning feature of the reader keeps it between that value of 0 and 1023. So you can see if we're in the middle, we have some slight condition variance. the reader will auto tune one way or the other from that, you know, roughly 600 value of capacitors. So that
So
takes
is
care
the
of.
optimal range from 400 to 600 then?
Yes, I would say that's a good place to be. Now there are situations where maybe we run out of adjustments on the adjustable cap board, and we're at, let's just call it 400 or 350. Now the antenna is going to work and perform and tune just fine at that value. So it's more of a guideline than a rule. If we can get this to tune, if we can get our antennas to tune between 0 and 1023, the antenna will function and will tune properly. So it's that center 400 to 600 is optimal, but it's not the end all be all, right? If we're at 200 tuned, we have good current, low noise, all that kind of good stuff, we're good to go. Hope that answers the question.
It does,
Okay.
thank you.
Yep, you bet. So we're going to move on to the pass-through, and this beautiful Boise morning is creating some sunshine here, so hopefully Elsa can work with me on the camera angle here. So what we have to display here in the pass-through orientation, again, the enclosure options. This is our small job box, which allows for internal batteries. So this will actually accept up to 4 of those 115 amp hour group 35 case size batteries in the bottom of this enclosure. And what we have here is a small solar controller, which in this case will operate up to 2 panels. This is what I was going to show you underneath the reader enclosure that we have for the pass-by system. Contains just a small solar controller. We protect your batteries, we protect the solar panel, protect the system from any ground faults or shorts or anything like that, using some breakers. We regulate our equipment so that it gets a constant 24 volts. Sometimes with solar, you can actually see up to 30 volts coming out of the solar controller, in which we don't want to cause any issues with the operation of our equipment. So again, in this case, we're kind of showing the pass-through orientation using the serial DOP configuration, which in your shore-base box is what you'll see here is the serial DOP enclosure, which includes a Bluetooth data logger, the DOP board, and then again our 24-volt regulator for the system. Now, in a actual system, we would plug our exciter cable. Those are available in 20 or 100, or really we could go probably a little bit further if necessary, depending on your application. But basically, this exciter or DOP cable will plug into your serial DOP box, and then what it does is it extends out and connects to a waterproof submersible reader enclosure. We call it a node. In this case, we call it a serial DOP node so that it works with the serial DOP enclosure. So basically, it's got quick connections or waterproof overmolded connections on both ends. Everything in here is watertight, so this can be submerged. And what it does is it decreases that distance between our reader enclosure, our reader, and our antenna. So that overall distance is about 5 feet, which gives us the most current that we can push to the antenna as possible. So like the pass-by orientation, we've got the 60-foot Litz in pass-through orientation with the same serviceable adjustable cap assembly. And what we'll do for you in the pass-through orientation is go ahead and get this as close to possible for in a 60-foot Litz orientation. The dimensions are going to be fixed at about 55 by 4 feet. So 4 feet tall, 55 foot in length. And what you see here for the installation of this is we've run a tag line between these 2 trees, and basically just went ahead and zip tied straight to that tag line going out there. And we understand that field applications are sometimes a little bit variable. So when we've done our testing, we've actually gone between about 3 and 5 feet, because we know that variation in substrate levels when you're out deploying this in the field can vary, right? Whether or not there's a thalweg in the river, or just a non-uniform substrate level going all the way across. So we'll get this tuned for this type of orientation, so that you should be able to plug and play. Just go ahead and install your tag line, get this all set up, and then be able to hook up the system, and it should tune. Again, you go through the same sort of cap adjustments if necessary. You'll just, for the pass-through orientation, sometimes it's a little bit more difficult to get the serviceable cap assembly out of the riparian area, or out of the water's edge. So that's just something to keep in mind when you're doing it. I think that's pretty much the gist of what we have for products for the Litz Cord. Again, they're available in 30, 40, 60, and 80-foot lengths, and that's loop length, right? So multiply that by 2, and that's the amount of cable we have out here. But the loop length is what's published. So I know that gets that's a frequently asked question. How much cable do I actually have out there? And those published lengths are loop length.
And Gabe,
So
can a passover
yeah.
antenna be used in pass-through design if the dimensions are changed?
So that's a great question, and I think the answer is a little bit loaded, right? So leaving here, we would like to know that if you plan on using the antenna in both pass by and pass through, we can supply little capacitor jumper packs that actually kind of affix to the adjustable cap board, so that you can be successful in tuning at either locations. It's easy enough to go ahead and remove those cord rungs if you have it in pass by, and then switch to using it in pass through. So yeah, that's definitely an option for us. It's just something that when you work with your one of us project managers, or you work with your salesperson, we'll need to know that upon purchase, so that we can kind of explain to you the difference and how to install those jumper packs successfully. And yeah, I think that's completely an approach we could take for sure. So I'm going to open it up to questions. I hope I covered most of the basics for the system. If you have questions, please let us know. We're more than willing to answer any questions that you have. Really dive into what you're trying to achieve. Try to get the best application or best fit for your study, and then just let you know of all the options that are available, whether it be solar power, whether you have AC or mains power. We also have thermoelectric generators for really remote sites that we can get these systems to operate on. So we have a lot of solutions and are really focused on what your specific needs are. So with that, I'd like to open it up for questions and do my best at answering any that you might have.
Yeah, Gabe, we have another question. What is the best way to store the components between projects?
Yeah, so that's a great question. The nice thing about the pass through or pass by orientation is once those rungs are installed, you can actually kind of roll it up almost like a rope ladder. So again, off of the antenna, you have an overmolded connection. So those disconnect. Your cable from the antenna back to the enclosure should roll up. Those can be stored, I guess in a cool, dry area. They've been deployed in some cold temperatures, so really the cold shouldn't really affect it. Biggest thing about if you have batteries in your enclosure, you'll want to take those out, and probably honestly, if it's going to be a long time, hook them up to some sort of trickle charger in order to keep them safe. Usually put those in some sort of environmentally controlled area, so they don't get really cold when they're semi-discharged. But as far as the components themselves, I mean, I think they're tested down to about, I think it's like a -4 degrees Fahrenheit or something like that. We do environmental tests on that, so cold really shouldn't affect them. They just need to be stored in kind of a rodent-free, bug-free area.
Thanks, Gabe. And then we have another one. Can this system be used in a low energy saltwater environment?
That's a great question. I know that we have tested some of the Litz cable in different configuration in saltwater. Saltwater has a really big influence on RFID equipment. You know, it robs a lot of the current that goes to the antenna. Definitely a great question, and one that we'd be willing to test for you. I would say it's always challenging in saltwater environments to actually put out an antenna field that's large enough to do what you're asking it to do, right? Detect animals, detect fish, whatever it may be in those environments. So definitely something, if you'd want to follow up with me on that, maybe we could get some testing done on that. But I know that specifically we have not attempted to use the Litz cable as far as any one of these 30, 40, 60, 80 feet in saltwater.
Thanks, Gabe. And what has been Biomark's experience with using Litz cords near or on concrete, such as a fish ladder or concrete box culverts?
Right. So in those applications, it's always tough, right? One thing that sets the Litz apart from, let's just say, a fixed HDPE antenna is the separation between the actual conductors or wires in the cable and then that concrete surface, right? With a 4-inch, 3-inch HDPE antenna, we've actually got maybe 1.5 inches or so of spacing between the actual wires inside the antenna and the surface, where the Litz cord is sitting directly on it. What we run into in facilities all the time is that we have no idea what the lattice of the rebar within that concrete looks like. And I know sometimes it's challenging. We'll get that that feedback. We'll have the loading effect of all this current into the rebar. We have been successful in applications of just laying this on a concrete surface. I know we have one application in Canada that it's basically just kind of a channelized area and just a concrete slab, and we basically just kind of wedge anchored this thing in place, and we're getting good results. So I guess there's not a direct answer to that question, but I know that we have been successful. What can be challenging too, and is not always the application, is trying to use the pass-through Litz in a facility. Again, the separation between our antenna coil and that concrete is very, very minimal. So maybe it requires, you know, building some sort of frame to set it away from the concrete itself, and maybe we can get by. We can have a little bit of separation there, let the antenna breathe and create that antenna field in those applications. So yeah, I hope I answered your question, but I know it's a little bit difficult.
And then when would we know we need to ground the reader box?
Good question. Grounding's another tough one too, because you know, in some applications we'll get a noise loop on the system, and grounding the system allows that noise somewhere to go to basically terminate, right? We give it an earth ground, so that noise basically has somewhere to terminate at the end of that ground cable. It's not always a perfect science, you know, on a conducted, where the noise is coming in from a conducted source, whether it be your power supply, something like that. I think we have a better shot at grounding that noise out. But sometimes that emitted noise coming from a frequency-driven motor, anything in that 134.2 kilohertz wavelength on the system, isn't always easy to get rid of. So I think it's a case-by-case basis, and sometimes you don't know until you try it.
Perfect, thanks. I don't see any more questions at the moment. So if anybody has any last minute questions for Gabe, please send them now.
And if anybody has further questions, please reach out to customer service at biomark.com. You can get me to gabe.derrick, DERRICK, at merck.com. Yep, you can forward any of that information or any of those questions to me. If you need additional information, I'd be happy to speak with you over the phone, via email, anything like that.
So we do have one last question.
Yeah, go
do
ahead.
you all have other ideas on anchoring methods? We found the duckbill anchors were not effective in soft substrate.
Right. It's a little tough. So I've actually seen some folks use some sort of Trex channel or channeling. I'm not really sure how they anchored that in there. It might have been silted in somewhat, but basically they ran channeling along the river, and then basically used or removed the rungs, put the cable in that channeling, and then it kind of had a plastic cover over the top of it, and then it kind of silted itself in. I know that's not always the greatest thing, but at least it ran the length of the river. I've seen folks try sandbags. I've seen folks try rocks. Yeah, you just want to stay away from any ferrous material. So, yeah, I think the sky's the limits on how exactly in those cases that you can get it to stay. We do have some longer duckbills with actually switched cables on it. I mean, we did one on the lower Colorado River where we were having to go down about 6 feet into the substrate because it was the exact same thing. We were in some really fine silty area, and it took us 6 feet to get down into good enough substrate in order to keep the system in place. So yeah, it's always difficult in soft substrate to get stuff to stick or get stuff to stay. There's no limitations on any of your ideas that you may have.
Perfect. Thanks, Gabe. I think that just wraps up our questions. Thanks everyone for joining.
Yeah, I really appreciate everybody taking the time, and look forward to speaking to you.
And for those of you that might have missed the beginning due to login issues or want to share, we will be sharing the recording. So I'll either send that out this afternoon or tomorrow. Thanks.
Thanks.